Hello everyone, I'm Professor AKRUTI from Ahmedabad Institute of Technology. Today we will see one more video lesson on functions. In previous video lesson we have seen basic function call, how to declare a function, how the function is called in program. Today we will see of these functions, that is about function call and recursive function. As you can see, function call, or we can say parameter passing, are of two types. One is about call by value, second is call by reference. Before jumping to this lesson, please refer to the functions part 1, which is named as user defined functions. So basically, let me get into a summary of that functions part 1. Whenever we are talking about the parameter passing, it was about actual parameter and formal parameter. When we declare a function, the parameter which we use is known as formal parameter, and when we call a function, the parameter which we use is actual parameter. Whatever we define in a function with the use of formal parameter actually gets implemented when we pass an actual parameter. Okay, so now we will see the call by value and call by reference method of this. So let us see first of all the definition of it. What is a call by value method? In this, values of actual parameters are copied to function's formal parameters, and these two types of parameters are stored in different memory locations. In call by value method, whenever any changes are made inside the functions, they are not reflected on the actual parameters of caller function. We will see this concept with an example. Now, the second method is about call by reference. We are just looking through the definition. We will see both this concept with an example. The difference between call by value and call by reference is that in this call by reference method, actual and formal parameters refer to the same locations. So if any changes are made inside the function, they actually reflect on the actual parameters. Okay, so we just have to remember two things. In call by value, we are using different memory locations. As we are using different memory location, change in one memory location will not impact the change in other memory location. In call by reference, we are using both the parameters on same location, so change in one parameter actually gets affected on the second parameter. Let us see the example of it with the C program. So here it's an example of call by value method. So what I have done is, first of all, as we all know in C program, header file inclusion is there. Hash include stdio.h. Okay. Now the name of my function is demo change, and there is one parameter of integer data type, that is num1. That's my variable. Okay, so in integer main, now as my main function is needed, without main my program cannot run. It is the must function which should be in any C program. So in main, I'm defining the value of x as 10. I have declared it as an integer. Now the first sentence is about before function call value of x. So the 10 which I have stored here, it will be printed here. Now my next sentence is demo change, and in bracket I have used x. What is demo change? Demo change is the function which I have declared with formal parameter number 1, num1. Okay, and here my actual parameter is x. So you can see the value of x is 10 here. When this sentence will get executed, that is passing value in function, what my compiler will do, it will directly find what is my function. So as you can see here, after the main completes, I have defined my function here, which I declared before my main. So you can see in this function void demo change, I have mentioned it with its formal parameter. The first sentence in this program is about printing the value, that is before adding value inside function, my number 1 variable. So what happens here, when I call this function, it will implement all the things mentioned here on this actual parameter. So whatever things that will be done to num1 variable, which is my formal parameter, same thing will be implemented on actual parameter x. So the first sentence is adding the value inside the function in which I am only printing the variable, so x will be printed. So as you can see the output here, The first sentence in integer main was about simply printing the function value, that is before function call value x. So you can see before function call my value is x 10 here. Now what was my second sentence? As you can see, I have called my function. The second sentence was printing the value of num1. Now what is num1? Num1 is my formal parameter. Whatever I'm doing to formal parameter, that will be implemented on actual parameter. So here while calling the function, my actual parameter is x. So you can see in output the value of x is getting printed here. Okay. Now next sentence in this function is num1 is equal to num1 plus 10. Once every sentence of this function gets executed, then only it will jump to the sentence after the function declaration. Okay, after the function calling. So now in demo change, my next sentence was after adding the value, num1 is getting printed. After adding value inside function, this num1 is getting printed. That means my x is now x plus 10, because whatever I'm doing to formal parameter, that will be done on my actual parameter x. So now x is 20. Okay, x is 20 in which function? In my demo change function. So here when I'm printing this value, it can see in output after adding value inside function, number 1 is 20. Now all the sentence of this function has been completed. So what it will do, it will shift to the sentence after the function calling. So now my next sentence in main function is printf after function call the value of x. Now see in output you can see after the function call x is equal to 10. So what was the difference here? We have made x is equal to 20. Still it's printing x is equal to 10. Why? Because in call by value method of parameter passing, the values are stored in different memory locations. So the x called here is no doubt the actual parameter, and it's getting the value of this num1 formal parameter, but it stays only inside this demo change function. Once it comes to the main function, the value of x doesn't get changed. It prints same x which has been declared. So that is the main concept of call by value. Actual and formal parameters are stored on different memory locations, and the value is never changed inside the function by the caller. No doubt in calling function it is getting changed. Okay, x is getting printed here, but only till the demo changes in execution. Once it returns to the void main, the integer main here, you can see the x is 10. Now, there is one more difference between call by value and call by reference, that was about memory location. So when in call by reference is used, this obstacle is overcome. Now we can change actually the value of formal parameter as well as the actual parameter. So before going to the call by reference, let me tell you one thing. This concept is regarding the pointers. In call by reference, we are using pointer. In upcoming video lesson, we will learn about pointers also. I'm just giving a summary here about pointer. Pointer means one kind of variable which stores the address of another variable as its value. Let me give you one example. Suppose I am having one pointer. It is always mentioned as a star. Suppose my pointer is star A, in which I am storing the value m%b. Whenever you are assigning a value in pointer, it is always mentioned as ampersand. Why ampersand? Because we are referring to the memory location. So suppose I'm writing one pointer star A is equal to ampersand b. That means in variable A, the value of memory address of this b variable is stored. Here the value of b is not assigned to A, but the value of A is the memory address of variable b. So suppose b is 5 and it is stored in memory address 220 in my memory. Okay, suppose I'm having one memory address like 220 and the value of b is equal to 5. So suppose I'm writing star a, that means the value 220 is stored in variable a. So you can in general say in pointer memory address of a variable is stored as a value. So in call by reference here, we are taking the function void demo change as previous example. Now my pointer is star number 1, in which I will be storing the address of my actual parameter. In main function, I'm taking the x variable as previous. Okay. In output also you can see. In print, I'm printing first of all before function call value x. So x is printed as it is 10. Now I'm calling my function because I'm dealing with pointer. So here while calling the function, my actual parameter is the memory address of this variable x. Okay. So now when I will jump to this sentence, you can see in this function in void demo change, first of all, I'm just printing the value of this variable. So you are dealing with pointers, so you will mention star always with this value. So the first sentence is simply printing the value of x. So you can see here in num1 the value is 10. Now the second sentence, as the previous example, we are adding pointer also deals with the arithmetic operations. So in star num1 I'm just adding 10. In star num1 my value was 10. So now it's 10 plus 10 20. Okay. Whatever I'm doing to num1, that is actually affected on x because x is my actual parameter. Okay. Now my next sentence is printing this value. You can see I have printed it as 20. So now when you return to this, the value of x, which was 20 here, actually gets copied to this pointer location also. Okay, and here you can see in output, in function call, my answer is x is equal to 20. So basically there is one main difference between call by value and call by reference is their memory location. My formal parameter and my actual parameters are actually getting stored at same memory location. Second difference, which was that updation of value. Here the value of x which is getting doesn't only stay inside the demo change function, but it actually stays in whole domain. So whenever I will call formal parameter and actual parameter, both of things will be stored in the same memory location, and that's why updation in one value is getting changed in second. So that was the concept about the call by reference. Now we will see what is the function with recursion. So here it's a concept about recursive function. Recursive function means when a function calls itself, it is known as recursion. Okay, suppose I'm having one function like void function 1. In function block itself, it's calling its own. So when I'm calling void main and it's calling void function 1, this function will also call itself again. So that is the recursion. Repeatedly calling itself is recursion. We will see this concept with an example. So this is most important question that has been asked in almost all the exams about finding the factorial of a number using recursive function. So we will see this example with this code. Now there is one more concept about function declaration. Normally in previous examples what we were doing, first of all header file was there. After that we were defining the function with the semicolon. Then void main was there in which we were calling the function, and after that we were defining the whole function block. Now there is also a second way to declare and define a function. Instead of semicolon here, we can directly declare the whole function. Okay, after that also we can write void main and we can call the function. So these are two methods for calling a function. So in this factorial of a number, I have taken one long function, long factorial integer n. Long is the data type, as you have seen unsigned, signed, integer, long integer. Okay, so that kind of data type is long here. So in this function, my parameter is n of integer type. I'm defining this function, so this is my formal parameter n. If n is equal to 0, return 1. Why I have used this sentence? 0 factorial is always 1. If my n is not 0, then I have to return n into factorial n minus 1. So this is my recursion. Okay. Now how this works, let us see. In void main, I'm taking one variable integer number. I have taken one more variable of long data type fact. So I'm entering a print message, enter a number. Now I'm scanning it into this variable which I have defined it over here, integer number. So whatever number user enters, it will be stored in this. In output, you can see enter a number. I have entered 5. Now what is my next sentence? In fact variable, I'm taking factorial of number. So I have to find the factorial of 5 which is stored in number. So I have mentioned it factorial of number. So what it will do, it will directly jump to the function declaration and definition. So what happens, my 5 is not 0, right? So my if condition is false here. So now it will go to else, n double is equal to 0 condition is false here. So it's going into else. In else I have mentioned return n into factorial n minus 1. That means my number was 5. So now what it has to do? 5 into factorial of n minus 1, that is 5 into factorial of 4. So when it will counter the word factorial of 4, what it will do? It will again jump to the function call. Now what happens? Is 4 double is equal to 0? No, 4 is not equal to 0. So again condition is false. So it will jump to this sentence. So what it is now? So 5 into 4 into, again there is factorial of n minus n, that is 5 into 4 into f of 3. That is my factorial of 3. Okay. So once again when I am calling factorial of 3, it will go to this sentence. It will check this condition getting false again and it will jump to this sentence. So now I am having 5 into 4 into 3 into factorial of 2. Right. So till 1 it will print this 5 into 4 into 3 into 2 into 1. And when it will counter the condition and 0, it will go to 1. So now the next sentence is, now my n is 0, no further conditions are there, so it will go to the main. All the sentence of this block got executed. In main I am printing factorial of this percentage d is percentage ld. Since it's long variable, we have taken this control sequence, control symbol ld. Okay, so I'm printing both the things. So you can see in output factorial of 5 is 120. So basically it got implemented as 5 into factorial of 5 minus 1, 5 into 4 into factorial of 4 minus 1, 5 into 4 into 3 into factorial of 3 minus 1. So till it reached to 1, when 1 into factorial of 1 minus 1, 0 was there, it returned 1 and we got this message printed. So that is the basic example of factorial with the recursion, a recursive function. Okay. So that's how the part 2 of the function ends here. If you are having any doubt, you can ask. Thank you.